Hello everyone. Today we would like to present our Sudoku project about the influence of Sudoku extensions on the solving speed. Our presentation consists of 5 main parts. First, the introduction. Throughout this paper, we will mainly focus on the Sudoku puzzles with unique answer. And we can define Sn to be the collection of all Sudoku puzzles with unique answer that has n clues. There's a fact about Sn. Namely, 17 is the least n such that Sn is not empty set. This means that there are no 16-clue Sudoku puzzle that has unique answer. We can also define so-called an extension of Sudoku puzzles. For Sudoku puzzle C with clue sets clue C, a Sudoku puzzle C prime is an extension of C if C prime has clue size of n, and every clue of C is also a clue of C prime. Let's see an example. This is a 17-clue Sudoku puzzle. And if we give the number of the first grid, then we get an 18 extension of it. And if we offer the two numbers for the two grids, then we get a 90 extension of it. And this is our data set. Then let's come to the question and hypothesis part. We mainly focus on two questions. First, does adding clues significantly speed up solution? Second, if so, is there any Sudoku puzzle whose solutions is more accelerated than others? We make these hypotheses. We expect that adding one clue to Sudoku puzzles with small clue sizes will significantly improve the solving speed. And besides, we expect that such improvement will decrease for each extra clue. For the second question, we expect that most of the Sudoku puzzles will perform uniformly with clue addition. And perhaps there exists Sudoku puzzle that perform significantly better than others with regard to clue addition. So we can now set up our experiment. For the dataset, we choose the first 170 clue Sudoku puzzles in our big dataset as shown in the previous slide and call the set T17. And for the 18 clue Sudoku, we consider all the 18 extensions of each C in T17. For n is 19, 20, and 21, we take for each Sudoku in T17, 10 extensions of it. We also implemented a Sudoku solver based on Pico sets, and we also included each Sudoku by the propositional conjunction normal form. Now let's do the concrete question. For question 1, in order to see if adding one clue accelerates the solving speed of n clue Sudoku, we do the following hypothesis test. Hypothesis 0 says that the average solving time remains the same, and hypothesis 1 says that the average cost time is less than the original solving time after clue addition. Besides, we can also calculate how much time is saved by adding k clues. We may define big delta n as the following, which means the average percent of saved time by adding n clues to the original Sudoku puzzle. For question 2, we mainly measure the coefficient variation, namely the CV, for n extensions of Sudokus in T17. The intuition for CV is that it's kind of standard variation, which measures the dispersion of data points around the mean. In that sense, bigger CV means that the points are farther away to the mean on average. And that means that either some Sudoku perform very bad or some Sudoku perform very good. So we implement our experiments and get the following results. For question 1, we get the following table for p-value about the test n to n plus 1. This p-value shows that it is very statistically significant that adding one clue will shorten the time for Sudoku solution, since we see that the p-value are much smaller than the usually used 0.005. As for the average saved time, recall that the big delta n records the average percent of time saved by adding one clue to a Sudoku, and we get the following table. We can also calculate the average saved time contributed by each extra clue. And for this, we find something strange, namely the second extra clue saves more time on average than the first, while after that, the average saved time by each extra clue decreases, as we expected. So we try to think about some explanation for this phenomenon. The first one is that there is actually a very deep difference between the 70 clue Sudokus and the rest in our dataset. Namely, all the Sudoku in T17 are minimal Sudoku puzzles, while their extensions are apparently not. However, we're still not that clear about how this would affect the solving speed. The second explanation is due to the set solver we have used, namely due to PyCoset. Now let's turn to question 2. Recall that in question 2, we mainly try to measure the CV, which reflects the dispersion extent of the performance of Sudokus under clue extensions. And below are the results. This is the results for 18 extensions, for 19 extensions, for 20 extensions, and for 21 extensions. We see that most of the Sudoku puzzles in our dataset perform actually quite uniformly under clue extension. In fact, over 90% of the CVs are smaller than half, which means that they are quite close to the mean. However, there are some exceptions, especially 2 extreme exceptions. One in the case of 18 extensions and another 21 extension. So we went to the original raw data to see what happened. As we have mentioned before, there are 2 possibilities for very big CV. Either it performs very bad, or either it performs very good. And the case here is that both of them perform very bad. There exists one extension in both cases that the extension is even slower than the original Sudoku puzzle on the solving time. However, we do not know how to explain this because we expected that maybe some Sudoku puzzles perform extremely good because of its good properties, but we don't understand how it can make solving times even longer. Okay, so far let's go to the summary and reflection part. To summarize, first we have seen that adding even one single clue to an n-clue Sudoku puzzle will significantly accelerate the solving speed. Besides, for 70 clue Sudoku puzzles, the second extra clue turns out to save more time on average than the first, which is a strange phenomenon that we want to solve, that we try to explain. For the second question, we find that most of the 70 clue Sudoku puzzles perform uniformly well under clue extensions. However, there are 2 extreme exceptions whose solving time even grows under certain extensions. And for these, we have some potential work that we can do. The first is to enlarge our dataset so as to make our prediction more precise. The second is that we can do some similar work with other set solver. This is mainly because we want to know if our set solver, PyCoset, does generates these strange phenomena that we have found in our experiments. The third work we can do is to work on minimal n-clue Sudoku puzzles for n is to be 19, 18, etc. This is mainly focused on the first problem because we guess that there may be a connection between the strange phenomenon of average same time and the fact that all the 17 clue puzzles are minimal while the others are not. And that's our presentation for the report. Thank you.